I feel like for real, boy.
Blue Nax production. Badass.
Electricity, vibe on a different PR, till infinity, steady on a different P.
I welcome you to another STEM communication. We are looking at mathematics today, and we are looking at simultaneous equation part 4. We have looked at part 1, part 2, part 3. This is part 4. The part is as a result of the methodology of solving, because a particular method can be specified to candidates in an exam that is used to solve problems that have 2 or more variables. That's why we need simultaneous equation. And that we use that require simultaneous equation. Use equations that have 2 or more variables. Now, we have looked at substitution method, elimination method, Cramer's determinant method. Please check out for my videos on all those methodologies. Today and right now, we are looking at another method that makes it to the part 4. That is inverse matrix method. I take that again, inverse matrix method. At the end of the day, I expect you to use this method to solve the following. This looks like advanced. Student offering further mathematics, student offering mathematics at any level in the university, advanced students, Olympiad students, SAT students, okay, Cambridge students. Yes, this particular method is very, very good for you. And you're using the method to solve some problems that has to do with surge, indices, and sequence. This is arithmetic progression. So you should be able to apply this method and any other method used for solving simultaneous equation to solve all this as well. Okay, now let's go. Inverse matrix method. Now let's assume that I have a problem. I want to generate a problem now. I have 2x plus 3y equals to 5. Then x minus, okay, let me put minus 2y equals to 3. Now, these are 2 simultaneous equations. 2 simultaneous because there are 2 unknown, x and y. I want to use inverse matrix method. It means you must know how to find inverse. There are some steps you need to follow to find the inverse of a matrix. So now it means that I need to render this equation to matrix form. Please put it here properly. How do you write this in matrix form? You bring out the coefficient of all these variables, x and y. The first coefficient is 2. Sorry about that, 2. The next one is 3. The coefficient of x here is 1. 1 is in front of it. The coefficient of y here is minus 2. You put it in matrix. Matrix is open and closed bracket. What are we looking for? We are looking for x and y. So x will be on top, y will be below in matrix form. Then the result is what? 5 and 3. You also equals to, you put it in matrix form. Is that clear? That's the first step. Okay, render to matrix. Render to matrix form. Okay. Now the next step is now this one, well, don't forget it's x and y. Now you assume that this is A, this is the matrix. This one, assume that this one is big X. Then this one is the result. What we are looking for is this big X, which represents x and y. So it means I need to divide both sides by this. So it means that this x is r over m. Now in mathematics, take note of this. Let me tell you how they come up with inverse. Look at how they come up with inverse. This is it. Now, if I want to bring this up, it will be r dot m inverse. If you take it, now it is 1 raised to power 1 here. If you take it up, it becomes raised to power minus 1. That is the idea of inverse. It means that I need to find the inverse of this m. I know that this m represents this matrix. Hey, this m represents this matrix. That means I need to find the inverse of. So then I will not come back to this formula later. Don't forget that I will come back to this. These are major formula. Then I need to find this inverse of. So second step is that find the inverse of m. Now m is what? Our m is 2, 3, 1 minus 2. Now step for finding inverse. Steps for finding inverse. It has step. Step 1. Please take note. Step 1. Find determinant of m. Find determinant. This is the symbol for determinant. This two stroke, then m in between. Determinant. So let's find that. M determinant. Check for my video 3 on this. You understand what I mean by determinant. You want to find, so that means determinant of 2, 3, 1 minus 2. You will change it from matrix to determinant symbol. Okay? Now, if you do like this, that is minus. If you do like this, that is plus. That is symbol. Now, let's find determinant. 2 times minus 2. You know you are doing like that as plus. 2 times minus 2. Minus 4. Minus 4 times plus. Minus 4. Then, you cross like this. That is minus. 1 times 3. 3 times minus. Minus 3. Minus 4 minus 3. That gives us minus 7. That's step 1. Determinant. Step 2. Find cofactors of m. Hey, find cofactors of m. You said let the cofactor, which is c now, let it be equals to a, b, c, and d. Do you know the meaning of cofactors? Let me explain to you. The meaning of cofactor is that what will replace this element 2, element 3, element 1, element 2? If it is not 2, what will it be? If it is not 3, what will it be? If it is not 1, what will it be? If it is not minus 2, what will it be? That's the meaning of cofactors. C. Now, how do you find cofactors? You will do sign interchange like this. You start with plus. Don't forget plus. The next one will be minus. Then here, two signs cannot follow each other like this or like this. So if this is plus, this one will be minus, and this will be what? Plus. Don't forget, start with plus. Now, it means that, look here, I want to find the cofactor of these two, which is A now. It means I will come to this place. What sign is for this A? You know it's plus, you put plus. Then you open the bracket. Now look at the element A, which I want to find the cofactors of these two, which is this A. You come here, at this two, you strike down, at this two, vertically down, then you strike horizontally. Which one remains? Minus 2. You put minus 2 here. Plus times minus 2, minus 2. Then you come to this place. I want to find the cofactors of this 3, which is this B. You come to 3. From this 3, strike down. From this 3, strike horizontally. What is left is what? 1. So it means B. Don't forget that the sign for B is this. You put the sign. Now let's do it again. Strike like this. Strike like that. What remains is 1. So what is minus 1 times plus 1? That's minus 1. I want to find the determinant of 1, which is this C. Can you see that? It corresponds to this C. C. What sign is there? Minus. You put minus first. Now from this one, I want to find the cofactor. You strike like this. You strike like this. Strike vertically, strike horizontally. What is left is what? 3. You put it in brackets. So what is minus times 3? That's minus 3. Alright. Now, I want to find the last one. The determinant of minus 2, which is D. D. Okay, how do I do this? You come to this place, up and like this. What is left is 2. What sign is there? That's plus. Then I have 2. Yes. So that gives us plus 2. So the cofactor now, you now replace it now into matrix form again. What is A? Minus 2. What is B? Minus 1. What is C? Minus 3. What is D? Plus 2, which is 2. Plus 2 means 2. Okay. Now, let me continue with this. Don't forget, we are still coming back to this, our equation. Where can I clean now? I need to clean some stuff. Now, I will clean this. We are coming back. I will not clean this because we need this formula. Okay? I will clean this. We are coming back to this formula. I told you we are looking for our x and y. Now, this step 3 now. Please put the something here. Step 3. You find the adjoint of m. Hey, look at that adjoint. The meaning of adjoint is that you find the transpose of cofactors. Now, cofactors, that's the meaning of adjoint. So you find the transpose of cofactors. So that means adjoint is equals to. Now, where is the cofactor? This is the cofactor. What does it mean to transpose it? Transpose. Take note of that. Transpose of cofactors. Now, if you look at this matrix has rows, horizontal arrangement, and column, pillar, vertical arrangement. You will turn when you transpose this, then the transpose of cofactors, c raised to power t. That's the meaning of adjoint. Let's transpose it now. It means these rows, the one that is standing horizontal, will now stand vertical. You will turn it like this, as if you squeeze it like this. So minus 1, minus 2 will now be minus 2, minus 1 like that. Then minus 3, minus 2, that is horizontal, will now be vertical. Minus 3, 2. That's the meaning of transpose. Is that clear? Now, step 4. You find the inverse now. Inverse. Don't forget inverse of m. That's m raised to power minus 1. This one. Hey, bring it here. You are trying to find the inverse of this. M raised to power. So the inverse now, m raised to power minus 1, is now the adjoint over determinant of n. Don't forget we have found the determinant already. Which means adjoint is the transpose of cofactor. That is c raised to power t over determinant of m. Do you get that? All right. I want to clean this. I want to clean all this now. I expect you, this is STEM communication. You are supposed to be writing as we are teaching. You are not supposed to just be looking, okay? You're supposed to be writing down every bit of thing that I'm writing and be following and be listening. Now, so it means that this inverse, m raised to power minus 1, is this, which is the transpose of the cofactor, minus 2, minus 3, minus 1, 2, divided by the determinant. What do you get for the determinant the other time? I cannot recall properly now. We got, oh my God, I've cleaned it. Can I stop? Stop it. So, like you said, the inverse now is adjoint over determinant, which is ct over this, okay? Now, the adjoint is the cofactor of the transpose of the cofactor, which is this. The determinant is minus 7. Now, the meaning of this is that this is 1 m inverse. This over this means 1 over minus 7 into this. That's minus 2. Minus 3, okay, minus 1, then 2. Now this number, this minus 1 over 7 is a number. It multiplies each of the elements in the matrix. We call this one element. This is a number multiplied by matrix. So this number multiplies each element. So that means the inverse would be this. Minus 1 over 7 times this, that would be 2 over 7. Because minus times minus will be plus. This, that would be 3 over 7. Minus 1 over 7 times minus 1, that will be 1 over 7. Minus 1 over 7 times 2, that will be minus 2 over 7. Do you get that? Now, you will now recall. You recall that our big X is result multiplied by the inverse. Now, this our big X is actually X, small x and y, if you recall. Okay? Being equals to the result is 5 and 3. This R stand 5 and 3. I'm referring to that equation that led to this. Then this one now, dot means times. We know this to be this 2 over 7, 1 over 7, 3 over 7, minus 2 over 7. Now, that's it. Now, these are two matrices now. Two matrices. You've got to know how to multiply two matrices. Let me just teach you in a very simple way so that we can get our x and y. Now, look at this. To find this, what you do is that you will pick this, the column, will multiply the first row of the second matrix. This column, this is just one column. You use to multiply this to get the whole answer. You also use this also to multiply this to get the second row result. Let's see. Very simple. It means that this will be 5 times this. 5.2/7 plus, if 5 go for this, it means 3 will go for this, plus 3.3/7. Is that clear? Now, again, you use this same column to multiply this row to give us the second row. So this one will go for this, 5 times 1/7 plus, then this 3 will go for this, 3 times minus 2/7. So our xy will now be this. Look up. 5 times 2/7, 5 times 2, that is 10/7 plus 9/7, 3 times 3. Okay? Then below we have 5/7 plus times minus 3 times 2, that's minus 6/7. Now, we'll come back to this place. Let's hand it up. Okay? Now, if you look at this now, this is now xy in matrix form. Now, you add this together. 10/7 plus 9/7. Find the LCM. That will give you 19/7. Then 5/7 minus 6/7. That will give you minus 1/7 in matrix. Now, you now compare this with this, you compare this with this. Can you see that? So our x now is 19/7, our y is minus 1/7. That is inverse matrix method. To master this, I will advise you go over this video 2 or 3 times and hold your pen and just follow the step one by one until you get it. Okay, because it's a bit technical and it has steps. So anything that has steps, the only way you can master it is to go over it over and over. So this video, watch it for the first time, second time. By the time you do that for the third time, then you will have known the step. Is that clear? Alright, now we have some problem for you to encounter here. I've already explained something like this. I'll just shed light for you. This one is straightforward. This one is recommended for students from SS2 who have done arithmetic and geometric progression. They're able to flow with this very well. Then this one, let me just explain. If you look at this, I told you that so many topics lead to simultaneous equation. This is radical, this is surd. And if you look at this, you can see some similarity of repetition of certain terms or surd terms like with x, with y, with y. When you see something like that, just replace it with something. Just say let with x be something maybe a, then with y maybe b. So that the equation will now become 3a minus b equals to 5. Then you have minus a minus 2b equals to 3. So you can use this method or any other method, but in this case I want to use inverse matrix method. Just render this to matrix form. The coefficient 3 minus 1 minus 1 minus 2. What you are looking for A and B in matrix from A, B. Then the result 5 and 3. Then you can get this solved using this method or any other method. There are so many methods you have been exposed to now in simultaneous equation. Now, at the end of the day, let's say you get your A, I'm not very sure, as 1, and you get B as 3. What you're looking for is not A and B, it's X and Y. You will now recall this. You forward all this. You recall that with X is A, and A is 1. How do you get X? You square both sides. If you square this square will disappear, it will be x. And what is the square of 1? That is 1. 1 times 1. Then again, you recall that root y is b. This will be root y. B is 3. How do you get your y? You square both sides also. If you square this square will disappear with this square. That will be y. And what is 3 squared? That's 9. So this one is just a guesswork. You have to find the actual value for a and b and do it this way. So that is very simple. There's no big deal about that. Okay. Now the next one is this one. If you look at this, you can see that you can see 2 raised power x, you can see 3 raised power y, and it cannot be splitted further. There's no way you can break 2 and 3. Now, then the only issue now is this one. Look at this. They gave you 2 raised to power x plus 2. You will need to break it like this. Law of indices, 2 raised to power x times 2 raised to power 2. Because this is what they do to get this. Is that clear? Now this is 4. That means this is like say 4 dot 2 raised to power x. Is that clear? Alright. Then this other one, 3 raised to power y plus 1. It also means 3 raised to power y times 3 raised to power 1. Law of indices. Okay, so this is equals to 3 raised to power 1 is 3 dot 3 raised to power y. You will now select anywhere you now see 2 raised to power s, let it be any letter, maybe a and b. You now substitute and solve. So this is very good for from SS1, further mathematics to SS3 down to the university. Attempt, get registered, and let us see their feedback. They will respond appropriately through appropriate channel once you are fully registered with us. Keep subscribing, sharing, and supporting. Till next time we meet, do have a wonderful time. Bye.
I feel like for real, boy.
Blue Nax Production.
Electricity, vibe on a different beat, till infinity. Steady on a different beat. Life is not that deep. It's all about the energy.